We're going to go ahead and graph the sine function and the cosine function in section 6.4 and 6.6. So we're going to work with graphs of the sine and the cosine function, and then we're going to do phase shifting and sinusoidal curve fitting as well. So the sine function's period is equal to pi. Cosine of x function also has a period of pi. So if I wanted to draw it over one period, I'm going to restrict the sine function from 0 to 2 pi. So that's the portion that I'm going to go ahead and draw. So the sine function goes up, it goes back down, and then it goes back up. And again, we're drawing it between the 0 and the 2 pi. So this part is 2 pi. This in the middle is going to be pi. This would be pi over 2. This would be 3 pi over 2. And this function also oscillates between -1 all the way to 1. So then we have 5 basic key points given this sine function. So one of them is 0, 0, the other one is at pi over 2, 1, the other one is at pi 0, 3 pi over 2, -1, and at 2 pi 0. So let's go ahead and graph or write the 5 key points. And again, we said it was 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. We're going to use this later in order to make other sine functions with transformations. So again, I drew this function between 0 to 2 pi, so that means that the domain for this restricted sine function over one period interval is from 0 all the way to 2 pi. And the range, because it oscillates between -1 to 1, then that means that the range is going to be -1 to 1. So a few things of this function. So the period we said was equal to 2 pi. That's the distance of one cycle. So I drew it over one cycle or over one period. The cycle goes between 0 to 2 pi. The period is equal to the distance of this cycle. So the distance between here and here, the distance between 0 to 2 pi, is equal to the period, which is equal to 2 pi again. So that's the period. It's a distance between the left and the right side of this cycle. And now for the amplitude is going to be the distance from the center of the graph to the top of the graph, and from the center to the bottom of the graph. So in the center we have 0, and then the top would be a 1. So the distance between these two would be equal to 1. So that's equal to my amplitude. The distance between the top and bottom is the amplitude, which again is equal to 1. So what we're using again is we're using the center all the way to the top, or from the center all the way to the bottom. The distance from the center to the bottom is also equal to the amplitude, which is equal to 1. Let's go ahead and graph the cosine function also. So for y equals cosine of x, and again I'm drawing it over restricted x values, so I'm drawing it only over one cycle, or in other words over one period. So I'm still going to draw it between 0 to 2 pi, just like I did for the sine function. But the cosine function looks a little bit different. So it's going to start at the top, then it's going to go below the axis, and then it's going to go back up. And this is supposed to be symmetric. So this is from 0 all the way to 2 pi, and the middle is going to be pi. This one's going to be pi over 2, and this one's going to be 3 pi over 2. This cosine function oscillates also between -1 to 1. So then this point, the 5 basic points, are at 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. So let's go ahead and write out the 5 key points. So again, it's 0, 1, pi over 2, 0, pi -1, and 3 pi over 2, 0, and 2 pi 1. So those are my 5 key points. Now for the domain for this function, for this restricted function still, is between 0 to 2 pi, because again I only drew it for one cycle. So 0 to 2 pi. And the range is what it oscillates between. So it oscillates between -1 and all the way to the positive 1. So the range is from -1 all the way to 1. So the next part is to graph these functions, but to graph them in with transformations. So before I do that, let me go ahead and go over the period on this picture as well. The period is the distance between the left and the right edge. So the period is also equal to 2 pi, just like for the sine function. And the amplitude, just like for the sine function, it's the distance between the center, so the middle of the graph on the y's, and the top of the graph, or the middle to the bottom. So the distance for each of these is equal to 1. So that means that the amplitude is equal to 1. Alright, let's go ahead and now let's go over graphing with transformations. So the way that I'm going to write the function is y is equal to a cosine of b times x minus c. So basically, if you have anything inside of cosine, you want to put it into this form. If you have anything inside of the sine, you want to make sure you put it into this form. So we don't want a constant other than 1 in front of the x. So if there's any constant in front of the x, you want to make sure that you take it out. I'm going to do some examples later of that. You also want to make sure that b is bigger than 0, meaning that it's positive. If it's not positive, then what you want to do is you want to use y equals cosine of negative theta is equal to cosine of theta. So we're using the fact that cosine is an even function, and we want to also change any sine of negative theta into negative sine of theta. So we want to make sure that we're using, again, the fact that for this one, that sine is an odd function. So we want to use these properties if necessary. Whenever b is not positive, you take out the negative. For cosine, you just ignore the negative basically because it's an even function, and for sine, you take out the negative. So what we're going to do first is we're going to find the amplitude, and the way that we can tell what the amplitude is based on the function that's given to us is we take the absolute value of the a. So whatever number is on the outside, you take the absolute value of that. Period is going to be equal to 2 pi over b. So we're going to take 2 pi and divide it by whatever number we have in the front. And then the phase shift is going to be c. So this is minus c. If you had a x plus a 3, for example, then this number, phase shift, is going to be the opposite of what you see in here. So if you had, for example, x minus 2, then the phase shift is going to be just 2, positive 2. If this is x minus a 10, then the phase shift is going to be 10. So we always take the opposite of what we see in here. The cycle is going to start at c. So originally my function started at 0, but if I have a phase shift, that just means that I shifted my function either maybe to the right or to the left side. So if I shifted my function to the right side, then that means that this new location is going to be at c, which is again the phase shift. So we're going to start at c, and then we're going to go ahead and add the period, whatever the period is. So for example, if I use that same rule for the original sine function, then that means that the amplitude in this one is equal to 1, period is equal to 2 pi over b, there's no constant in front of x, so that means that b is equal to 1, so the period is equal to 2 pi over 1. 2 pi over 1 is equal to 2 pi, that's what we had here before too. The phase shift is equal to c, so because there's no number after the x, then that means that the phase shift is equal to 0, which means that I'm going to start my sine function at 0. So if you look at the cycle, it starts at 0, and then you take the, so c is equal to 0, and then you take that 0 and add the period. We said the period was equal to 2 pi, so that means that we're going to start at 0, and then we're going to end at 0 plus 2 pi, which is equal to 2 pi, and that's exactly where we ended. So that also gives me the restriction on the domain, again, for this restricted function over one cycle. So the next part is going to be to find the length between each of the 5 key points. Since we're going to use the 5 key points that we used before, or we're going to tweak them a little bit, we're going to take 1/4 times the period. This is equal to 1/4 times whatever the period is. I would say don't memorize this part, just know that it's 1/4 times the period. So let's go ahead and do an example. So we're going to graph this function over a 1 period interval. So the first thing I want to do is I want to find the amplitude. So let's go ahead and find the amplitude. And the amplitude is equal to absolute value of a. So a is equal to 3. We take the absolute value of 3. This gives me back a 3. Next thing is to find the period. So the period is equal to 2 pi over b. And b is equal to the 2 in this case. So 2 pi over 2 is equal to pi. So now we're going to go ahead and find the phase shift. The phase shift is whatever is next to the x on the right side, and you find the opposite of this. This says minus pi over 4, so it's going to be positive pi over 4. So the phase shift is equal to positive pi over 4. Again, it's the opposite of what you see in this portion. And the next part is going to be to find the cycle. So we want to figure out what two numbers or what two x values does this function oscillate in between. Well, not oscillate in terms of the y's, but where does it fit in between? So cycle is going to be starting at the phase shift. So starting at c, and we said c was equal to pi over 4. And then we're going to take that pi over 4 and we're going to go ahead and add the period. So it's going to be pi over 4 plus a pi. So if I add pi over 4 plus pi, we're going to go ahead and find common denominator. That gives me 4 pi over 4. 4 pi over 4 plus pi over 4 gives, 4 pi over 4 plus pi over 4 gives me the 5 pi over 4. So this is pi over 4 and 5 pi over 4. So my cycle begins at pi over 4 and it ends at 5 pi over 4. Now I want to find the length between each of the points. So the length between the points is going to be equal to 1/4 of the period. We said the period is equal to pi, so 1/4 times pi is equal to pi over 4. So this is telling me the distance between each of my points. Had I done this one for the original sine function, let's go ahead and do that for the original one. 1/4 times the period, we said period was equal to 2 pi. So let's go ahead and simplify. 1/4 times the period of 2 pi, this is equal to pi over 2. So the distance between each point is equal to pi over 2. Let's check to see if that's true. Distance between this key point and the next one is pi over 2. Distance between this one and this one is pi over 2. Same thing with the next ones, and same thing with the next ones. So the distance between the points that I'm drawing, the 5 key points, is equal to 1/4 times the period. So in this case, it's pi over 4. So what I need to know is first my starting point. My starting point is based on the cycle, which was based on the phase shift. So we're going to start my function at pi over 4. So that's the first x value. X equals pi over 4. And again, this one is based off of my starting point on the cycle. So those two have to match. And then my second point is going to be this pi over 4, the previous one, plus the length between the points, which in this case is also pi over 4. So again, we're going to take the previous one and we're going to go ahead and add the length between the points, which is this one. And then we're going to go ahead and simplify. So pi over 4 plus pi over 4 is 2 pi over 4, and that gives me back a pi over 2. And we do the same thing, so we keep adding a pi over 4 until we get to the end of the cycle. In this case, until we get to the end of 5 pi over 4. So then we're going to take the pi over 2, which again came from the previous one, and then plus pi over 4. And this pi over 4 is again the length between the points. So we're adding the length between the points again until we get to that last number in the cycle. So if I add these two, I'm going to get 2 pi over 4 plus pi over 4. That gives me 3 pi over 4. So the first x value is pi over 4, then 2 pi over 4, then 3 pi over 4, then 4 pi over 4 until I get to 5 pi over 4. So if I wanted to do it algebraically, I'm going to go and add another pi over 4 to the previous one, so 3 pi over 4, which is the previous one, plus my length between the points, so plus pi over 4, and again, this came from the length, and that's equal to 4 pi over 4, which is equal to pi. Now the last one is going to be the previous one, so pi plus pi over 4. And if you didn't want to keep changing and finding common denominators, just use the one that has the over 4 on the next one. That way you don't have to find common denominators. It would already be given. So this is equal to 5 pi over 4. So my x values are going to be pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. Let's go ahead and draw out the x values at least for now. So my starting point is going to be at pi over 4. Then we have 2 pi over 4. And the way that I'm going to write it on this graph is going to be not reduced. So these fractions are not going to be reduced. So this is just going to be so that I can find these easily. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And if you wanted to, of course, you could go and simplify these. So we also know that the amplitude is equal to 3. This tells me the distance between the center and the top of the graph. So because this function doesn't have anything added to it at the end, we know that this function is technically centered at the 0 here. So it's centered on the x-axis. Let's say we had a +1, so on the outside here, then you would have to shift it up by 1 and go the amplitude above that and the amplitude below that. So because it's at 0, or in other words, it's at the x-axis, we're going to go 3 above that and 3 below that. What that gives me is you go up to 3 and you go down to -3. So this is where my function is now going to oscillate between. So let's go ahead and graph, and let me actually label this for the amplitude. So we know that the amplitude is equal to 3 because that's the distance between the top and the bottom, and we know that because absolute value of A was equal to absolute value of 3, which was equal to 3. Alright, so again, I know that my starting point is at pi over 4. Let me go ahead and draw the sine function just so that I can use it as a reference to know whether it's going to start on the bottom or if it's going to start at the top. So I'm going to start matching points to the sine function. We know this sine function starts in the middle, goes up, goes back down, and then goes back up. So this is my first key point, that's my second one, that's my third one, then that's my fourth one, and that's my fifth one. So my first key point is on the axis or on the center, let's call it the center. So my first key point is going to be at the center. We know that the first key point is going to start at the beginning of the cycle here. So this first key point that we had in the original sine function is going to match the first key point that we had in our transformed sine function. Now the second key point is above, so my second key point is going to be at x equals 2 pi over 4, and we're going to go all the way to the top, to 3. The third key point is on the axis, so the third key point is on the axis here as well. So the next one is 4 pi over 4, or pi, and this next one is below the axis, all the way at the bottom, so this one's going to be all the way at the bottom as well. And for 5 pi over 4, that's the fifth key point. This fifth key point is on the axis, so we're going to draw it on the axis as well. And then we're going to go ahead and connect these with that sine curve. And I'm not going to draw this over more than just one period. I'm just going to draw these for one period. So we're graphing it over a 1 period interval. If we wanted to graph it over a 2 period interval, I would keep going by pi over 4 to the right, or you could keep going to the left, and you would copy this exact same shape on the right side.